This is Pre-Calc section 11.4 on matrix algebra. This video will show you how to find the inverse of a 3 by 3 matrix using row reduction. The previous video showed you how to find the inverse of a 3 by 3 matrix using cofactors and determinants. So this is a different method. This is the method that the current book uses. So just a definition here. When a matrix does have an inverse, it's called non-singular. And if the matrix has no inverse, it is called singular. In your homework, they will refer to a singular or non-singular matrix. So there's a definition for you. So the way to do this basically is you are going to take the original matrix. That's the matrix we want to find the inverse of. And we are going to create a bigger matrix. And that matrix will have the original matrix in the first 3 columns. And in the next 3 columns, what you're looking at is the identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. When we finish, we will have the identity matrix right here, and you will be left with another 3 by 3 matrix right here, and it's going to be the inverse matrix. So it's just a matter of doing the row reduction, which we have already learned. So this is the same matrix I had on the other page. I just copied it over so I'd have more room. We know when we are doing row reduction, you want to have a 1 in this first position and have zeros here and here. So since I have a 1 in the position I want, I am just copying that row over. And it's my pivot row. It's the row I'm going to be using to help eliminate the other values. And to eliminate this, I don't know if this helps or not, but I'm just going to cover up this 3rd row because I'm just dealing with the first row and the 2nd row. I want to get rid of that positive 2. The only way that this positive 2 will go away is if this right here is a negative 2. And the way to make this become negative 2 is to multiply the entire row by negative 2. Now perhaps you can do the multiplying and the adding in your head. If you can't, you can just jot down right here negative 2, 0, negative 2, negative 2, 0, 0. And what we're adding together will be that blue row in this row right here. So negative 2 plus 2 is 0. 0 plus negative 2 is negative 2. Negative 2 plus negative 1 is negative 3. Negative 2 plus 0 is negative 2. 0 plus 1 is 1. And 0 plus 0 is 0. Now I want to do the same idea. Get rid of this. Now I want to deal with the first row and the 3rd row, so let's just cover up the 2nd row. And you don't have to do that covering up. That's just to get that out of your field of vision so that you don't grab the wrong number. To get this 3 to go away, it would add with a negative 3. So to make this number a negative 3, I need to multiply this whole row by negative 3. So if you distribute negative through there, this is negative 3, 0, negative 3, negative 3, 0, 0. The first row and the 3rd row together, negative 3 plus 3 is 0. 0 plus 0 is 0. Negative 3 plus 0 is negative 3. Negative 3 plus 0 is negative 3. 0 plus 0 is 0. And 0 plus 1 is 1. So that's my first couple steps there to get the 1 in the first position here and zeros underneath. The next thing I need is a 1 right here. And the only way I'm going to get a 1 right here is to divide that whole row by negative 2. So 0 divided by negative 2 is 0. Negative 2 divided by negative 2, I said negative 2, I didn't write the negative, there we go. Negative 2 divided by negative 2 is 1. Negative 3 divided by negative 2 is positive 3 halves. Negative 2 divided by negative 2 is 1. 1 divided by negative 2 is negative 1 half. And 0 divided by negative 2 is 0. Now, so I don't make an arithmetic mistake, what I do, once I get that row I want, I've got the 1 in that position, I take these 2 rows and I just recopy them so that I don't make some silly arithmetic mistake or line things up improperly. So this right here, also, I don't have to do this right now, but I can divide out a negative 3 on this row too, just to make the numbers smaller. A negative 3 in those 2 positions. So I choose to divide the whole row by negative 3. You don't have to do that, but I just like to get the numbers smaller. So this is 0, 0, 1, 1, 0, negative 1/3. Now at this point, I have the 1 in the 2nd row, and I need zeros in those 2 positions, and miraculously I got them. Usually you don't. Usually you have to do a little bit of work to create those, but in this particular problem, I have the 1 in the 2nd row. I have zeros in that second column, so I'm good to go. Also, by doing my division by -3 right here, I created a 1 right there, which is the next place I need a 1. So I'm going to copy that row right here. So 0, 0, 1, 1, 0, -1/3. And then that's the row I'm going to use to eliminate these two. They'll start back on this matrix to see how I can get rid of this and this. So let's cover up this middle row and just deal with the first and the last row. If I'm going to cancel out this 1, that means this needs to be a -1. So I will multiply this whole row by -1. -1 times 0 is 0, plus 1 is 1. -1 times 0 is 0, plus 0 is 0. -1 times 1 is -1, plus 1 is 0. That's the 0 I was creating. -1 times 1 is -1, plus 1 is 0. -1 times 0 is 0, plus 0 is 0. And -1 times -1/3 is a positive 1/3, plus 0 gives me 1/3. So that's my new top row. Let's repeat the same process. Let's move this cover up this way. And now I want to work to get rid of this positive 3/2. And the way to do that is to multiply this row by the opposite, which is -3/2. So -3/2 times 0 is 0, plus 0 is 0. -3/2 times 0 is 0, plus 1 is 1. -3/2 times 1 is -3/2, plus 3/2 is 0. -3/2 times 1 is -3/2, plus 1 is -1/2. -3/2 times 0 is 0, plus -1/2 is -1/2. And -3/2 times -1/3 is a positive 1/2, plus 0 is a 1/2. And we're finished because right here, this is your identity matrix, and these last 3 columns make up our inverse matrix. So our inverse matrix is 0, 0, 1/3, -1/2, -1/2, positive 1/2, and the bottom row is 1, 0, -1/3. One where we do not have a positive 1 in that position right there. So here I went over here, and there's my original matrix, there's the identity matrix, and there's last 3 columns. What I did here was to create a 1 in that upper left position. I just multiplied that whole row by -1. That's how I got that row. Also, I noticed that I want a 0 in that position, and I have a 0 in that position. So I think about that being like a freebie. So that row got copied over here. I just did that to save a little bit of time. We'll also then copy the middle row as is, just so that I have the completed matrix in front of me. Now I'm using the first row as my pivot, so the first row just gets rewritten right here. And the bottom row, we already said, had the 0 where we wanted it, so it gets copied again. And the work I need to do right here is to get rid of this positive 4, so I will multiply the top row by -4 and add it to the middle row to cover this bottom row up, and do my arithmetic. -4 times 1 is -4, plus 4 is 0. -4 times 1 is -4, plus 5 is 1. -4 times 1 is -4, plus 0 is -4. -4 times -1 is 4, plus 0 is 4. -4 times 0 is 0, plus 1 is 1. And -4 times 0 is 0, plus 0 is 0. So at this point, I have my 1 in that upper left position with zeros below. I also happen to have gotten a 1 in this position where I wanted it without having to do any work. So it is now my pivot row, 0, 1, -4, 4, 1, 0. And that's the row I'm going to be using to create zeros here and here. So if I multiply this row by -1 and add it to the top row, let's move this over just so it's covering up for me. So -1 times 0 is 0, plus 1 is 1. -1 times 1 is -1, plus 1 is 0. -1 times -4 is 4, plus 1 is 5. -1 times 4 is -4, plus -1 is -5. -1 times 1 is -1, plus 0 is -1. And negative 1 times 0 is 0, plus 0 is 0. So same steps. Let's move this out of the way. That's a positive 1. I want it to cancel out with a negative 1, so I will multiply negative 1 through the middle row and add it to the bottom. So negative 1 times 0 is 0, plus 0 is 0. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times negative 4 is 4, plus negative 3 is 1. Negative 1 times 4 is negative 4, plus 0 is negative 4. Negative 1 times 1 is negative 1, plus that was a 0 that I didn't copy for whatever reason. So negative 1 times 1 is negative 1, plus 0 is negative 1. And negative 1 times 0 is 0, plus 1 is 1. So almost finished. I have my 1 in the first row, or the first row, first column, and 0 is below. I have my 1 in the second row, second position, and 0 is above and below. The next thing I need is a 1 in that position, and I have it, so I will just copy that row over and then decide what I need to multiply by to get rid of things. Let's bring this over, cover up the middle row. Doesn't do a great job of covering, but you got the idea. To get the 5 to cancel out, this would need to be a negative 5, and the only way it'll be a negative 5 is to multiply the whole row by negative 5 and add it to the first row. So negative 5 times 0 is 0, plus 1 is 1. Negative 5 times 0 is 0, plus 0 is 0. Negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times negative 4 is positive 20, minus 5 is 15. Negative 5 times negative 1 is 5, minus 1 is 4. And negative 5 times 1 is negative 5, plus 0 is negative 5. Let's move my little cover up here. And now I want to get rid of this negative 4, and the way to do that is to multiply this whole row by positive 4. 4 times 0 is 0, plus 0 is 0. 4 times 0 is 0, plus 1 is 1. 4 times 1 is 4, plus negative 4 is 0. 4 times negative 4 is negative 16, plus 4 is negative 12. And 4 times negative 1 is negative 4, plus 1 is negative 3, if I can squeeze that in. And 4 times 1 is 4, plus 0 is 4. So what you're looking at is these first 3 columns are your identity matrix, and these last 3 columns are your inverse. So let's rewrite this so it's not so cramped. So this is 15, 4, negative 5, negative 12, negative 3, 4, and negative 4, negative 1, 1.